8.2 Special Right Triangles. As if right triangles weren't special enough, we are going to learn about some extra special right triangles. The objective in this lesson is to use the properties of 45, 45, 90 and 30, 60, 90 triangles. And what we're going to do with these is simply we have some shortcuts. We're going to learn some shortcuts that allow us to determine the side lengths without having to use the Pythagorean theorem. So our first triangle here is a right isosceles triangle. And you may have noticed it when we looked at the angles. It's a 45, 45. So we know that two of our angles here are congruent. So the converse of the isosceles triangle theorem says that our sides are congruent. So if I'm looking for side measurements, both of them can be labeled x. And in our right triangles, we know that the first thing that we always do is find the hypotenuse. Our hypotenuse is over here. And so I can label A, B, and C. And we want to find the length of the hypotenuse in terms of our other two sides. So we know that A squared plus B squared equals C squared. So x squared plus x squared equals C squared. X squared plus x squared, that's just 2x squared equals C squared. Well, what is the length of C squared? I simply take the square root of both sides. Now, you know from when we were simplifying our radicals, we can separate out the pieces underneath our square root. And this is the square root of 2 times the square root of x squared equals c. Square root of c squared is c. And now x squared is a perfect square. So that can come out. So square root of 2 times x equals c. So the length of our hypotenuse, c, is x times the square root of 2. Now this is true for every right isosceles triangle. And it doesn't matter what the lengths of our legs are. The length of the hypotenuse is always going to be the length of the leg, one of the legs, times the square root of 2. So that's our first theorem here. We just proved our 45, 45, 90 triangle theorem. And it says that in a 45, 45 right triangle, both legs are congruent, and the length of the hypotenuse is the square root times the length of a leg. And so that gives us a formula here. And it also gives us a diagram. And you're welcome to use the formula, but if you learn the diagram, life will be a lot easier because this is a shortcut, right? And if you look in your best friend in your big packet, this diagram is in the big packet. And we see our right triangle here. We see that it is a 45, 45. So we know that both of the legs measure x, and the hypotenuse measures x root 2. So all you have to do is label your triangle as such, and then things will be super easy. You can also always use the formula. Both of these ways work. Labeling the diagram is going to be the easiest. So let's take a look at how this works. We want to find the value of the missing side, the value of each variable. And so in our first triangle here, we know that our leg here is 9, and we're looking for the length of our hypotenuse. Well, I know this one is 9 as well. And the first thing I'm going to do, well, let's look at the equation first. We know that the hypotenuse equals the square root of 2 times the length of a leg. Well, how long is our leg? It is 9. So I substitute in the length of the leg for 9, and I get 9 square root 2. I could also say this is x, and this side is x square root 2. Well, what do I know on this particular triangle? I know that x is 9. That's the length of my leg. So I can simply just put in a 9 here for x, right? You know how to substitute. X now has a value. You go and you find all the x's and you put in 9. So the hypotenuse is 9 square root 2. Let's look at the next problem. On this one, we're looking for the length of our hypotenuse. And so we have a leg and a leg. So we write our formula. Hypotenuse equals the square root of 2 times the length of the leg. And we simply substitute in. Hypotenuse is x. That's what we're looking for. And the length of the leg is 2 square root 2. So we now have 2 times the square root of 2 times the square root of 2. I just rearranged. And what is the square root of 2 times the square root of 2? That's 2 times the square root of 4. What's the square root of 4? 2 times 2. So we find that x equals 4. Now this is a little hint for you. Anytime you have a square root times itself, what comes out is that number. And for this reason right here, square root of 2 times square root of 2 is square root of 4, which makes it a perfect square. 2 times 2 is 4. So you can go through this step, or you can just go straight to, well, I know that square root times its another square root is just the number. And the reasoning behind that, what is this? This is the square root of 2 squared. Because what does squared mean? Squared means multiply it by itself 2 times. And square root are opposite operations, so all that's left is the 2. Now that works all well and good, but let's take a look here. This is x, and this is x square root 2. So what do? I simply put in 2 square root 2 times square root 2. I substitute in x and then multiply it by square root of 2. Your equation works exactly the same way. So it's your turn. Go ahead and pause the video and try to do the next problem. This problem was very straightforward if you did it just like the ones up above. We were told that we had a 45, 45, 90 triangle, and one of the legs was 5 square root 3 units long. So the first thing I did was I labeled x, and x root 2 on my hypotenuse. We know that this is the hypotenuse over here. And so I know that x is the number 5 square root 3. So the hypotenuse is x times the square root of 2. I substituted in 5 square root 3 and multiplied that by the square root of 2. The square root of 3 times the square root of 2 is the square root of 6. 3 times 2 is 6. I also used the formula. We know the hypotenuse equals the length of the hypotenuse equals the length of the leg times square root of 2. The length of the leg is 5 square root 3 times square root 2 is 5 square root 6. So both ways work very nicely. Let's look at the next problem. This problem here is going to be very good reference. We are given a 45-45 right triangle, and we are told that our hypotenuse is 6 units long. We want to find the length of a leg. First thing I'm going to do, x, x root 2. So what do I know here? I know that the length of the hypotenuse is the square root of 2 times the length of the leg. Well, 6 is the length of the hypotenuse. I just substitute that into my formula. Square root of 2, the length of the leg, is x. We want to solve for x. So how do we do that? We have the square root of 2. I'm going to switch this around here. X square root 2 equals 6. How do we solve for x? The square root of 2 is just like any other number. I am going to divide both sides by the square root of 2. And these will cancel. So what am I left with? X equals 6 divided by square root of 2. Well, that doesn't look like a very nice number, and it's not. It is generally bad form to leave a radical in the denominator. We like our denominators to be whole numbers. So we need to turn the radical in the denominator into a whole number. How do we do that? How do you turn square root of 2 into a whole number? Well, we multiply it by itself. And you know how fractions work. If you multiply something on the bottom, you have to multiply it on the top as well. And so that is going to give us 6 times the square root of 2 over what's square root 2 times square root 2? That's just square root 4, right? Or 2. And now I always look to simplify my fraction. What's 6 divided by 2? This is 3 square root 2. And this is how you will always rationalize your denominator. You want a rational number. Radicals are irrational numbers. This is called rationalize the denominator. All right, let's look at our other way of how to do this. I've labeled my diagram, and I know I can just put an equals sign in there and get 6 equals x square root 2, because I know that I have a number for that. And then we just simply solve exactly the same way to solve for x. And then we know that this is 3 square root 2 and 3 square root 2. And our hypotenuse measures 6. So whether you use the formula or just go straight from the labeling of the diagram, it's all good. This example here will help you remember how to rationalize the denominator. That's what that was called that we just did. And it's your turn. Pause the video, do the next problem. This was just like the problem we just did. We were told that the hypotenuse of a 45-45 right triangle is 10 units long. Find the length of the leg. So I drew my triangle. I labeled x root 2. And I know the hypotenuse measures 10. So I know that x square root 2 equals 10. This is just our formula. The length of the hypotenuse equals leg times square root 2. Okay, so then I divide both sides by the square root of 2. I get x equals 10 over root 2. We want to rationalize our denominator, multiply both top and bottom by the square root of 2. And I get 10 root 2 over 2. Simplify my fraction. X is 5 square root 2 units. So I can go ahead and label the rest of my triangle. Not bad. If you are careful and follow your examples, you will do just fine. Our next problem. What do we do in real life with square roots. It's all well and good in math to have accurate answers, right? Just like we did with circles. You might have 3 pi. 5 square root 2 is the same as 3 pi. It's an accurate answer. But you don't go to the lumber store and ask for 3 square root 2 feet of lumber. So we can use this, and when we get a square root answer, we simply put it into our calculator. And so this problem has a softball diamond is a square. That appears to be some important information. Squares are good for us, right? The distance from base to base is 60 feet. And how far does the catcher have to throw the ball from home plate? So here's home plate. Here's second base, first base. You can see that we have a right triangle here because it's a square and our 2 congruent legs. We are looking for the length of the hypotenuse. So I'm going to say x, x, and x root 2. And this is where knowing your shortcut really comes in handy. Because what do we know here? We know that x equals 60. Look at that, it's right there. X equals 60. And so what's the length of the hypotenuse? The hypotenuse is x square root 2. So our hypotenuse is 60 square root 2. Look how easy that is. I know this is x. I can just put a 60 right there. 60 square root 2. And this is real world, so we throw it into our calculator, and your calculator will give you this very, very long decimal. And we want to round that. So we can say it's about 85 feet from home plate to second base. Go ahead and pause the video and do the next problem. Another easy problem, if you followed the steps. I drew my garden, and I know that it's 100 feet on each side because it's a square, and we want to build a path along the diagonal. So I see I have a 45, 45 right triangle here. I labeled x, x, x root 2. We are looking for the hypotenuse. I know that x equals 100. The hypotenuse equals 100 square root 2. Throw that into my calculator. We get this long decimal. We are asked to the nearest foot. So the path is going to be about 141 feet long. Okay, so these are nice. You can see how it's a nice shortcut. We don't have to do all of the Pythagorean theorem. It would have been, we could have just done 100 squared plus 100 squared equals c squared, and we would have gotten exactly the same answer. This is just a shortcut that once you recognize it, it's very easy to just go, oh, well, that's 100, so it's 100 square root 2. Problem done. Let's take a look at our next theorem here. Now, we won't be spending so much time on this one because it's exactly the same thing, only different. This is 30, 60, 90 triangle theorem. So we have a 30, 60, 90 triangle. And in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is square root 3 times the length of the shorter leg. So the shorter leg is the important one for us. And we have 2 formulas here that you can follow. One for the hypotenuse, one for the longer leg. How would we find the length of the shorter leg? Our short leg would be what? Hypotenuse divided by 2. And what would our short leg be on this one? Would be our long leg divided by the square root of 3. And then we would rationalize our denominator. So it would be long leg square root 3 over 3. Okay, so let's take a look at our triangle here. How do we know where the short leg is? Well, we know where the hypotenuse is. The hypotenuse is always opposite your right angle. Now we learned back in chapter 5, how do you find the short leg? It's opposite the short angle. So who's the small angle here? 30. This is going to be our short leg, and notice it is labeled x because everybody's relative to the short leg. And our hypotenuse is 2 times the short leg. And how do we find our long leg? Well, 60 is bigger than 30, so this is going to be our long leg, not as long as the hypotenuse, but of the two legs, it's the long leg. And what did our theorem say about that? That it is the short leg times square root 3. So this is an x2x x root 3 problem. So we have 45 45s, which are x root 2, and we have 30 60 90, which are x2x x root 3. So the proof of this, again, is just the Pythagorean theorem. You can look through the proof here, and you just use the Pythagorean theorem to find it based on the length of a side. So let's go straight to a problem. Using the length of one side. Well, we know that we have a 30, 60, 90 right triangle, and we know that the length of one side is 5. First thing I'm going to do is find my short leg. It's right there. Find my long leg. It's right there. There's our hypotenuse. And I am going to label x, 2x, and x root 2. Where does the x go? X is the short leg. That's not the color I wanted. X is the short leg. The hypotenuse is 2x, and the long leg is x root 3. Well, what do I know? I know that x square root 3 equals 5. So can I find x? We sure can. We're going to divide by the square root of 3 on both sides. Those cancel. X equals 5 over the square root of 3. We rationalize our denominator, and we get 5 square root 3 over 3. Okay, so we know that our short side is 5 square root 3 over 3. That is x. So how do I find my other leg, my hypotenuse? We know the hypotenuse is 2 times x. I think I'm doing the next problem for you. I am. That's okay. Hypotenuse is 2 times x. So what do? We know what x equals. X is 5 square root 3. Actually, let's go back and write that a little better. We know that x equals 5 square root 3 over 3. There we go. So how do we find our hypotenuse? We know our hypotenuse is 2x. So that is 2 times 5 square root 3 over 3. How do we deal with fractions? Everybody's a fraction. So put that over 1. So how are we going to do this? Well, I have 2 over 1 times 5 times the square root of 3 over 3. How do you deal with fractions? You just multiply straight across, right? Straight across the top, straight across the bottom. So what's 2 times 5? That's 10 square root 3. 1 times 3, that's 3. So our hypotenuse length is 10 square root 3 over 3. So that was easy enough. Don't be afraid of the radicals. They are just numbers. They act kind of like an x, right? If we had 2 times 5x, it would just be 10x. A radical's kind of like an x. You can't multiply it in its radical form. All right. So we have one more example here. We're making jewelry. We have a pendant in the shape of an equilateral triangle. Why is that important? Well, because if we have an equilateral triangle, we know that this angle right there is 60 degrees. And we can drop an altitude down, right, making a right angle, and it would cut this angle up here in half, making that 30 degrees. So we are going to end up with a special right triangle that is 30, 60, 90. My triangle's not very straight there. Much better. And what do we know? We know the height of each pendant is 18 millimeters. So we go in, we identify there's our hypotenuse. I find the 30-degree angle. Across from that is my short side. The 60-degree angle is my long side. And then I'm going to label. Short side is x, hypotenuse is 2x, and long side is x root 3. So what can we say? We can say that 18, I'm going to use some of this space down here, x root 3 equals 18. Get x by itself. X equals 18 over square root 3. Rationalize our denominator, and we get x equals 18 square root 3 over 3. We can simplify that to 6 square root 3. So we know that this bottom side is 6 square root 3 millimeters. And then how would we find the hypotenuse? Well, the hypotenuse is just 2 times 6 square root 3, which is going to be 12 square root 3 millimeters. All right, these problems are a little bit challenging, so I think I will go through this last problem here with you so you can see how it's done. Now, what are we told here? We want to suppose the sides of the pendant, so the sides of the pendant are 18 millimeters long. So what we're looking at here is now we have 18 millimeters on all sides. So that is going to change how we label our triangle. So I'm just going to draw a right triangle here. And we know that we drop that down. This is 60 degrees. This is 30 degrees. And so I have my hypotenuse here. This is my short side. This is my long side. And I'm going to label the short side x, the hypotenuse 2x, and the long side x root 3, because that's how it always is. And I know that my hypotenuse here is my side. This is 18 millimeters. So I know that 2x equals 18 millimeters. Divide by 2 on both sides. I get x equals 9. And that's what I'm looking for, because now I know that this side that's x is 9 millimeters, which should make sense because when we drop our altitude down, it is the perpendicular bisector of that bottom side, so it's obvious that that one is 9 millimeters. And then I just put a 9 in for x over here on my long side, and it is 9 square root 3 millimeters. So you see how easy that is. You use the one side you know to find x, and then you substitute it in everywhere else. So it's a little harder when you have to rationalize your denominator because you either have a square root or you know the side that has the square root, but you will get used to those. Those are pretty easy once you do a few of them. But especially this problem right here just illustrates we know that 2x is 18, so x has to be 9. So my short side is 9 and my short leg is 9, my long leg is 9 square root 3. I just substitute in for x. So these will feel a little challenging at first, but if you label everything, now I know I've said this a million times, but it's true. Label your sides and don't be afraid of the square roots. And I think that you will do a fine job on the homework. So enjoy.